I wish someone had shown me what a real Unity project looks like when I was starting out. Not just tutorials, but the full structure and how everything connects. Now, after 7 years of learning game development, that's why I'm making this video. I'm showing you exactly how my game is structured, the systems and how they connect, the folder and asset structure, and how the Unity scenes are set up. The whole package. Now, my systems are far from perfect, but it gets the job done. And I hope from this video you'll get a bit of direction and the confidence in knowing that your systems don't have to be perfect either. Let's first take a look at an overview of all of my systems in my game. And here you can see this kind of a diagram of my game, and it all starts with the game state manager. It's a script that basically keeps track and controls the state of the game and the flow of the game. It has access to all these kind of persistent systems, meta progression systems and achievements, and all the things that the player unlocks between the different runs. It also has access to the inventory services system, which contains player inventory and shop inventories and the player crafting recipes they have unlocked at any moment. And this basically communicates between all of the systems and the current level that is loaded at any given state in the game. And when the player wants to start a new game, or maybe the player transports to the next level, the game state manager loads in a new scene of the game and calls this level entry point. And the level entry point basically takes in some data that tells it what level we are loading, whether it's the first level of the game or maybe a boss level or a shop or a forge or whatever the level may be. And then using that data, it initializes all of the systems in the level with the correct state. And I found that this is, for me, the best structure so far for structuring my levels and my scenes. Because with this level entry point, it's super easy to make sure that everything gets loaded with the right data in the right order. So let's take a look at the level entry point in a bit more detail. So like I said, the game state manager, when loading a new scene, first interacts with the level entry point. And then the level entry point, it's basically a single point of entry. It's the only thing that needs to be called for a level to be initialized. And it handles initialization and linking all the systems together that needs to be linked. And it's really good for preventing these race conditions. For example, if you want to spawn your player, you need to first know the spawn point for the player. So basically the order in which the level is generated and the player is spawned is very important. If you first try to spawn the player, then you don't know where to spawn it. So you have to generate the level before you can spawn the player. And having a script that handles initializing everything in the level in the right order is super important. At least for my games it has been. And yeah, it basically makes loading in levels much easier, and there are fewer errors and problems with the loading. And it makes it so much easier to debug. So if the game state manager passes all the required data for loading any level in your game to the level entry point, then it's super easy to create these debugging scripts where you can customize the data so that you can from a console window load any level you want. This is much easier than having to piece together a bunch of different data for all the different systems when you want to load some specific game scenario. Now the other piece in the puzzle is these different systems that interact together in the game. For example, the game state manager and the inventories and particle effects and such. And the difficulty is basically how all of these systems are supposed to communicate with each other. And when you're developing in Unity, it's easy for some systems to just be dragged into fields in the inspector. And sometimes this is not possible. So for example, if you are spawning in enemies from prefabs, then you need to give the enemies access to other systems that are outside these enemies. Like for example, they may need to have access to the player's inventory if they, for example, want to give the player loot when they are defeated. So then the challenge is, how do we link these systems together that need to be linked? And a very software engineer approach is to have some kind of dependency injection framework. But honestly, I think it's an overkill, since our purpose is to make games, and if you are a solo developer or just a small team, then as long as you know what's going on, then that's good enough. So I use singletons a lot, which is for some very controversial, and it's because it's a bit of an anti-pattern and it has some issues. But basically what they are is, they are these classes that have global access to them. So for example, if you have an inventory manager class and it's a singleton, then any script in your game has access to your inventory manager at any time. And if you are familiar with programming, then you can instantly see like what kind of issues this might be causing. Now, while it's easy and fast to use, the downside is that it kind of creates this tight coupling and these hidden dependencies. And what this basically means is that, especially if you have kind of these singleton classes that are connected to each other or form these webs of calling scripts in other singletons, then changing one may, in the worst case, require you to change all of them. And additionally, from looking at the code, it's not clear what systems are interacting with each other always. If you have like more well-managed dependency frameworks in your game, then it's much easier to see which systems are connected to each script. But since these are globally accessible, then you'll have no way of knowing what other code is using these singleton objects. Now, still, it doesn't mean we have to be savages about this. We can still have some principles that makes it much cleaner and much easier to use, and basically makes it so that it causes much fewer issues. And one is having a public interface and a private implementation. So one way to have a singleton class is basically have a public static reference to the class so that the class can be accessed from anywhere. Now what I like to do instead is have the reference to the class instance be private, but then the methods are publicly available. So let's take a look at an example. So here's an example of what I was talking about. We have a camera controller with a private static reference to the camera controller instance. And in awake, we basically store this camera controller into the static field. Here in the initialization, we basically make sure that only one camera controller can exist at a time. And if we try to create a new camera controller, we'll just destroy it instead. Basically what this static means is that the static variable can be accessed from anywhere within your project. From any piece of code can reference this variable, whatever is stored in this variable. So since we in the awake method set the static instance variable to this, so basically the camera controller script that is calling this method, that means that then anywhere we have access to the camera controller instance. Although it's private, so only other camera controllers can access it. And then basically instead of giving full access to the class, we only give outside access to the methods that we want. So we have these public static methods for applying camera shake or applying hit stop. And in this public static method, then we can either call a private method for doing the action, or we can just have the implementation here through the instance variable. So now what this does is, if we don't have a camera controller in the scene, there won't be an error. Instead, nothing happens and we can log something to the console. And if we do have a camera controller, then it's the effect is taking place. And here's an example of how to use it. Basically, we have an example of an explosion class, and when the explosion is triggered, we can just call camera controller.applies camera shake and apply hit stop. So it makes writing code, like implementing features, super fast, at of course the cost of technical depth in some cases. So here's a couple examples of how I use this. Basically, all of these classes have to trigger sounds, so they call the Singleton interface, and then the Singleton interface calls the implementation. Similarly, the camera control example, we have the public method, which is the interface, and then we have a private implementation of the camera controller screen shake, which is not like the outside scripts don't have to know what's going on in there for the camera shake to work. And then finally, an inventory example. We have some kind of inventory service. It has public interface for adding items, removing items, crafting or buying or consuming items, and then private implementation. So you don't need to give everyone access to like changing the items. Only you can like limit the access to this script to only the interface. Like in large teams, this might cause issues, but as long as you're solo or in a team of like less than 5 people, I think this works just fine. So now it's time to take a look at the Unity part of things. So basically we're gonna take a look at how the game scene is structured, how the level entry point and the generation and whatever looks like, and how the game state manager and the inventory interact with each other. So here in the Unity, when we look at the hierarchy, we can see that here's our game state manager. And you can see that it's a Singleton class with a don't destroy on load thingy. Basically, this object will not be destroyed even when we load different scenes. This is important since every time we change a level, the scene is reloaded. So this game state manager would be destroyed without that. Then each scene has a level entry point, which has references to the world generation, different generators for creating the different levels, the basic levels, and then the forge levels where the player goes to craft items. And then the level entry point has also logic for initializing all of the different systems and for selecting which level to generate based on the data supplied to it. So basically the game state manager supplies some data. Actually, it should be a parameter here. Having it as a parameter here would make it so much better. Then we have a service locator, which is basically the inventory service. It has the player inventory and a forge inventory. If we were in the game and we get to the forge level and we get the items, then the items can basically be seen here in the first in the player inventory are the player's items, and in the forge inventory you can see the crafting recipes here with all the different configurations for them. Then we have this particle effects script, which is also a Singleton class that has public static method for emitting particle effects. And then my particle effect class has just configurations for how to emit the particles. I really like having this system. It makes it so that any script I have can, like, with just one line of code, it can display any of these particles without having particle systems on literally every object in the game. Like, all of the particles you see in the game are using that this particle effect system, and all of the different effects are just kind of child objects of this class. Then I have a level manager script. The level manager basically tracks all enemies and the player, and if I clear a room, and then it at some point reveals the exit for the next level. That's basically one of its current jobs, but there may be other level related events, and I will add them here in the future. Then I have these dividers in my hierarchy. Basically, we have the systems which we went through, then we have some debug and UI stuff, and then we have a main and a world. The main is just for camera, player and terrain, which are kind of the main objects that I'm looking for. So I want them to be here so they're easier to find. And then world is basically all stuff that is instantiated during the game. So when we click play, what happens is the game state manager tells the level entry point to load the first level. The level entry point then finds the level generator that is configured here in the generators, and then it basically takes the prefab and runs my level generation algorithm, which I can make a video on if you'd like. It basically first calculates the structure of the level, and then it populates it with ground, wall, ores, enemies and decorations, and does a bunch of other stuff as well. And then it also initializes all the other systems, basically the terrain, the level manager and other stuff like that. It basically makes sure everything is done in the correct order. And that's how the levels in my game are like initialized. That's how the systems work together. Then once you clear the level of enemies, the exit to the next level is revealed. And then when you go in, you are teleported into the next level. And that's basically how the same loop begins again. But now, of course, the game state manager has transported us into the second level instead of the first one. So the game state manager keeps track of which level we are on at any given moment. Now the project structure is ever evolving, but let's take a look at its current state. And just keep in mind that it's gonna change whenever new stuff is added and whenever I feel like refactoring the structure. So on the highest level we have different folders for different asset classes, I guess. So in the first one we have the level, which basically contains prefabs for all the enemies and the level assets that are found in each of the levels. And we have the scenes here as well. Then below that we have the behavior trees for all of the enemy behaviors, animations for everything. Then we have an art folder with material shaders, and then basically just all of the sprites for the game, and the Krita project as well, where I kind of draw the sprites. And after that we got audio, crafting recipes, editor scripts, my level generators for generating the different levels in the game. Basically these are the prefab kind of configurations that use the different modules. You can check out my level generator episode. No, wait, I don't have one yet. Well, you can subscribe if you want to see in the future my level generator video. How about that? Then logs. Here I basically log all of the seeds that my level generator generates when I'm in the game. So you can see I have generated more than 1600 levels for my game. It's only in play mode. If you generate levels for testing in the editor, they don't get logged here. But this is super useful. If I'm testing my game and I see something weird or strange happening, then I can use these seeds to basically recreate the exact same level. This really improves testability of the level generator and the game in general. Then this is a package for better UI stuff. I don't know if I have any examples here, but it's super useful for basically improving editor behavior in Unity. Then plugins folder, it just has fmod at the moment, which is for audio. Resources folder, currently all of my items are stored in the resources folder. This is basically so that the items can be loaded into the game at runtime. And after that I have the scripts folder, and yeah, it has a lot of stuff. There's a ton of different scripts. Some of them are simple and some of them are more complicated, but yeah, they're all in here in some kind of semi-logical order, and some of them I haven't yet put in any subfolder, and I should like clean this up. After that, this is for fmod, basically audio stuff again, music and sound effects. Then I have terrain. This is basically the tiles and the different terrain materials and such. I might move these into the level folder. I should probably do that. Then text and font stuff. I have UI icons and style sheet for configuring text. The icons are from a previous project. They're just placeholders at the moment, and the font is also just a placeholder. I'm gonna have to choose a different font when I get to making more UI for the game. Then Textures Pro and some setting stuff for different materials and renderers and whatever. So basically that's the whole structure of the project folder for the game. Now that's it for my game. I'm sorry if this was a little bit rambly. It's a bit hard to go through every system in your game without it feeling like an awkward house tour. But I hope you got some value out of it, and if you wanna see how it evolves, make sure to subscribe. See you in the next one.